Alright, so we're doing a problem with two means, independent sample. Got the data over there on the right. Let's check it out and read it though. A study was done on skull sizes of humans during different time periods. The results are shown in the table. Assume that the two samples are independent, simple random samples selected from normally distributed populations, and do not assume that the population standard deviations are equal. Alright, so it's pretty obvious when you're doing the homework. It says two means, so you know you're doing two means. But let's say you don't have that label, like on an exam. So how do you know what you're doing? Well, look at the table. There's an X bar. So if I have X bar, it's very, very likely that I'm working with means. But if you read Part A, at a 0.05 significance level, test the claim that the mean skull breadth is less than. So yeah, clearly I'm working with two means here. So by the way, the mean skull width in or breadth in 4000 is less than 4000 BC, less than that in AD 150. So that's a less than. That has to go in the alternative hypothesis. So I'm looking at A or B here, but you always have to have an equality in the null. So clearly that's got to be the answer then. All right. Jumps right into the test statistic and all that. So you, yeah, but I like to know, where am I at in the formula sheet? A lot of stuff going on here. I do have two samples, so I'm in one of these three columns. However, is sigma known? Remember, sigma is the population standard deviation. It does not give us those. So that means sigma 1 and sigma 2 are unknown. So we're in the second or third column. And on top of that, it also did say to assume, do not assume, that the population standard deviations are equal. So in other words, we should assume they're not equal. So that puts us in the third column, because over here they're not equal. The rest of the conditions we need to check is the population's normal or the sample's bigger than 30. And in fact, the samples are less than 30, but it does say up in the problem, assume that they're from independent simple random samples that are normally distributed. So all our conditions are met, and so we are going to work on that third column there. So let me jump over here. Null mu1 equal to mu2. Alternative mu1 less than mu2. By the way, this is the claim. This is pointing to the left. That means that's the side where our rejection region is going to be. Degrees of freedom is the smaller of n1 minus n1 minus 1 or n2 minus 1. And so we're going to go with that. If you go to the problem though, both of them have a sample size of 28. That is, by the way, having those sample sizes be the same is not necessary. They can be different. So there's our degrees of freedom. So I'm going to use that, my alpha, 0.05. I like to, as I say, I always like to get the critical value, get an idea, get a picture, get a visual. Where does this rejection region start? Critical values come from the calculator in StatCrunch. So stat, helps if you use the right thing here. There you go. Stat, calculators, T. Degrees of freedom was 27. Trying to find my critical value for 0.05. And there we go. So negative 1.7 roughly. So that's where my rejection region starts. So if we land over there, we're going to reject. All right, so next, T. We could write out the formula for T. It's a big nasty one. I do like to write it out, especially on paper and pencil tests, and then just let StatCrunch do the work. I'm not going to write it out for the sake of time here, but we're going to jump into StatCrunch and take it from there. So if you look at the formula sheet, it tells us where to go. Now this is not pooled, so it does say down the bottom there, be sure to uncheck pooled. So we'll make sure we do that. So we're going to get that over there, get this here, that way we can see that table of data. Stats, T-stats, 2 samples with summary. There we go. So 132.15, 5.42. Sample size was 28. Sample mean here is 135.75. Sample standard deviation 5.15. Sample size again 28. We're going to uncheck pooled, right? It's not pooled, and point my arrow to the left. Compute. There it is. So T-stat, our test statistic, and it's a T distribution, so that's where the T and the T-stat comes from, right? Negative 2.548. So let's go back here. Negative 2.548. And then what was P? P was 0.0069. All right, so if I throw my T on here, roughly in there, so clearly we're out in the rejection region. But again, we don't say, hey, look at my picture, compare P to alpha. Clearly P is lower than my alpha. If the P is low, the null's got to go. So we're going to reject the null. Well, if I reject the null, then that means I think the alternative is correct, and therefore I'm going to support the claim because the claim is in the alternative. Okay. So I got everything I need. So let's jump into the problem and get this going. So test statistic, I guess what was that? Negative 2.548. Short-term memory, rounded 2 decimal places, so negative 2.548, so 55. P was 0.0069, so 3 decimal places, 0.007. We're going to reject the null and support the claim, so that's answer A. All right, now they want us to construct a confidence interval. So just real quickly, if I jump back over here, let's make sure we understand the confidence level idea. So they didn't give us a confidence level to throw on here, but the idea is if we're going to link this to our hypothesis test, which I don't really like doing, but if this is 0.05, confidence intervals are symmetric. So if 0.05 was the size of that rejection region, we have to have symmetry here. So that means I need to think of 0.05 also being over here. Well, if I have 5% on the left and 5% on the right, that leaves me with what? 90% in the middle, which is where my confidence interval is. All right, so this means we're doing a confidence interval with 90%. Now, the nice thing is this is really easy to do in StatCrunch, and in fact, I don't even need to retype all my data. If I just come in here and I hit Options, Edit, it'll jump me right back in, and all that data is still there, and I can just come down here. Instead of selecting hypothesis test, I can do confidence interval. We're going to use a level of 90% for the reasons I just described. Hit enter, and there we go. So negative 5.965. Let's see here. It probably wants me to negative 5.965. Rounded 3 decimal places. Okay. Negative 5.965. Helps if you get the decimal in there. and what was the other one? Negative 1.235. Negative 1.235. Awesome. So there we go. Now, does this support the conclusion of the test? Well, yes, because if the first one is smaller than the second one, when you subtract them, you'll get a negative value. And our confidence interval is completely on the negative side, if you see that there. So that is supporting the idea that the first one is smaller than the second one. So yes, and that's because it contains only negative values. So again, implying the first one has to be smaller because our interval lands all negative. All right, got it. So hope that helped. So just subtle adjustments, you know, if the sigmas are known or not, if they're equal or not. So just subtle things, not really a whole lot different, and you know, just click a different thing here or there in StatCrunch, but pretty minor. And again, that formula sheet helps you out with that as well, that bottom row. So all right, so until next time, hey, keep calculating, I guess.